Right, kia ora guys, we're up to the second part of the assessment for 1.11 and what we should do in this part of the assessment. So you've got a whole period to do this, and in this period you will be writing up what you have found out by collecting the data from your first period. So you will open the second period document and all the information is on there, and we have a whole hour to complete it on your devices. First part of this part will be to draw your graph. So you've got to show that you know what kind of graph to draw and how to do it so it makes sense, so that somebody can read it and work out what you're talking about. So we do that by using NZ Grapher, and you'll have a link in your second document to the Google spreadsheet that you'll be able to do this with. So if we have a look at the example, okay, so there it is, all pasted into my assessment, exactly as it is. So remember that you need your units on the X and Y axis, and that your title should make sense of the graph. We've got our regression line, so that tells us what's happening, what the picture of the graph looks like, and that'll do for now. So the next thing we need to do is actually start to talk about the graph, because we never draw a graph without talking about it. So our first comment we're going to make will include things about its linearity. Anyway, whether it is linear or not. So we need to mention that. So I've put that in here, just here, because it looked pretty good, like a line. You can see that all the data is sort of forming a line there. We need to talk about whether it's positive or negative, and remember that positive means it's going upwards as we go across the graph. Negative means it's going downwards as we go across the graph. And strong or weak, that's the tricky one. So I'm going to say this is strong because it's quite tight around the line. Like I could put a little bubble around it and it wouldn't be too far away from the line. So I'm going to say that we can see from our graph, the regression line, that the relationship is a strong, positive, linear relationship. So we should have 3 words there. This means, well, what does it mean? So if we look at that graph, it means that as the length gets bigger, it appears that the width gets bigger too most of the time. All right? So that's what we're going to write. We're going to write, this means that as the length of leaves increases, the width of leaves tend to increase. We can't say it does increase because we might be able to find one that doesn't work. So we use that word tend to increase. Remember that if it's negative, you'd say it this way round. So this would say, as the length of leaves increase, then the width of leaves tend to decrease, which doesn't make sense because that's not true in our picture, but that's the words that we'd use to write it. Then we move on to our next paragraph, and our next set of comments, we want to talk about the scatter, the outliers, and the groupings. So the scatter is about the dots around our line, and as we saw in our graph, it's very tight. That means that we are calling this relationship strong. In this one, it's not quite so tight, so we might go for the word moderate, and in this one, seems to be all over the place, even though there is a line of fit. So we call this one weak. There's not a lot of relationship between all those dots and the line. Okay, so we just need to say that the scatter is very close to the line, indicating the relationship is strong. The scatter is not very close to the line, so I would call this relationship as moderate. There seems to be very little relationship between the dots and the line, so I might call that one weak. Then we go on to outliers. So when we're talking about outliers, we're talking about points that are perpendicularly this way, straight out from the line, a long way. So this one's a long way further from the line than any of the others here. We might call that one an outlier. In our graph, we didn't really have any that stood out. So we don't have any outliers, and this is not an outlier. It's really close to the line. That doesn't make it an outlier. This one's quite a way away, but I still don't think it's far enough to call it an outlier. So we would say we do not have any outliers in our leaves data. For groupings, we're looking at, are there sort of groupings with a gap in between in our data, and what's happening to cause this? So we would, if we can see that there are groupings, we'd need to talk about what may have caused it. Like in this case, there could be gender or age differences. So if you have males versus females, might be height or something, you might end up with two groups, or age. If you were looking at comparing year 13s to year 9s, you might have big groups at either end, and that would be because of age. This one about Old Faithful, so that's the geyser in Rotorua and eruptions there. So it may be to do with weather. These ones might be happening in the summertime, and these ones might happen in the wintertime. So I don't know. You've got to just sort of think what kind of things could be to blame for these things. So when we're talking about them, we should try and explain what's caused them. So we'll often talk about biological or geographical reasons, so where things are placed, or what biological relationship is between things. So here we go. It makes biological sense that the length and width of leaves would be a positive relationship, as when measurements belong to one thing, like a leaf or a person, it would be considered normal for measurements to increase together. All right, so some sort of sentence meaning you understand the context of what we're talking about. There could be geographical reasons as well, so I made up one here for the leaves, that one of the bushes we took leaves off may get more sun than the other, or maybe one side of the bush gets more sun than the other, and therefore there's a difference happening within that. But we don't know unless we actually look at where we've collected the data from. The last thing we do is write a conclusion. When we're summing up a statistical investigation, we always write a conclusion, and we do that by repeating and answering our question. Then we talk about how we could make improvements to whatever we've done to investigate a certain topic. So in this case, I've written, in conclusion, my question was, is there a relationship between the length and width of leaves collected off a bush at Tawa College? So from my data and graph, I can say that there is a strong positive linear relationship. That means as the length of a leaf increases, the width tends to increase. All right, so that's my conclusion. Now I'm going to talk about what else I could have done differently. So I may have a stronger argument if I use leaves from different plants and collect a bigger sample. Or the data may have been better if we flattened the leaves before we were measuring them. So I've just made 2 extra points there just to say I understand what we did and whether that will have an impact on the investigation we've done. All right, so that's it. Good luck with your test, and keep positive.